Hello, this is just a quick video to show you how you can find the tension in the two strings using the law of sines instead of using the components method, where you take the forces, the tensions, and you break them down into horizontal components and vertical components. Now, I'm just going to do a quick review of how to do it the other way. So if you want to find, and I already did the drawing here, so if you want to find T1 and T2, you're going to say, you know what? The object is not moving right and left, so the components of the tension right and left have to balance, and the components of the tension up, or the two tensions up, must equal mg. This way, the object doesn't move this way. So I think it should look something like this. T1 cosine of 30 is equal to T2 cosine of 70. In other words, F net equals 0 on the right and left. Same way up and down. So T1 sine of 30 plus T2 sine of 70 is equal to the mg, which is 50 times 10, which is 500. So now you can do a little substitution, and I can show you how I did that. So you can probably see that in the video there. So that's how I did the work to find T1 and T2. Okay, so I came up with the T1 being equal to one. Okay, I'll write it here. T1 is 173.65 newtons, and T2 came up to be 439.69 newtons. All right. Now that took a lot of work. You have to do a system of equations and stuff like that. Now, here is the quickest way you probably can use, and this can only work if you have two strings and a weight. If I have three strings here, I have to go back to the components, right? Because in order to do law of sines, I need a triangle. I can't have four segments, four legs. So the way it works is the combination or the resultant of T1 and T2 as vectors have to equal mg. So basically what I'm going to try to do is that I'm going to make a triangle with T1, T2, and the resultant of those two, which should equal to mg. Okay? Because it's not moving this way. So this is what it's going to look like. And I'm not going to draw this to scale. So T1 is this way. And we know that when we want to draw vectors, we do head to tail. And T2 has to be this way. Okay? And we know that T2 is bigger than T1 because it's more vertical than T1, but it's not drawn to scale. And here is the resultant. You always connect in the very first starting point to the final destination. So this is the resultant, and since the object is now moving this way, that resultant has to be equal to your weight, which is mg. So that should be 500 newtons. Now, if you look closely, this angle here is 30 degrees. This angle here is also 30 degrees. The angle that T2 makes with the horizontal is 70 degrees. So basically, this whole angle here, well, I'll keep that in there for now, 70 degrees, which leaves us with 20 degrees here, because inside this triangle here, 70 and this one should add up to 90. And in here, if this is 30, this has to be 60. So I'm going to erase everything I don't need. I don't need that. And this here, I'm going to make these two guys equal 100. And this is the magic of the law of sines, which makes the math pretty simple. Okay. So now I'm going to say T1 over sine of 20 equals 500 over sine of 100. I'm just writing the law of sines backwards, flipped. So I can find T1. And to find T2, I can say T2 over sine of 60 equals 500 over sine of 100. And just like that, with very little work, you will get your same answers. So in a fraction of the time. All right? Take it easy. See you later.